Hi guys. So in this video we'll discuss what is tokenizer and specifically OpenAI's tokenizer. So many people have this conception that we still use white space as our word boundaries and we separate out tokens using white space or space, but we don't do that. So it uses byte pair encoding to get the tokenized string. So be it prompts or even on the generation side, it generates one token at a time. These tokens are not really words. It's tokens itself. To know more about these tokens, we can dive a little deeper into this tick token library. It's from OpenAI itself, but it's specifically for OpenAI. So it's like a fast tokenizer library, uh, byte pair encoding tokenizer for OpenAI's model. Now this is not needed for us to build any projects, but this is just like a side note for for us to remember what is happening inside OpenAI's model as well, so that we know that like many people have this doubt that, oh, I only sent 3 words, why are they charging me for five tokens and things like that. So it really clarifies a lot of things and it's interesting as well. Now the best way to learn about it is this OpenAI cookbook that I've opened here in the new tab. I just go here. Yeah, this is all about like how can you actually count tokens. Like if you send this string, tick token is great, you'll actually get tokens as this. So T is one token, IK is one token, token is another token. So this one word has been broken down into 3 tokens. This is what this means, and that's exactly why our word never matches, or mostly in general never matches the tokens that are there. They have given like different encoders here. So these are different encoders that are used, and for which OpenAI model which encoder is used is what is given here. Now this is even though this is by OpenAI, it does not require any OpenAI API key or anything, so it is free. That is one part about this. So if you see, they have given like some code snippets here, how to use it. I have just set up a notebook so that it's easy for us. So first thing is like let's install tick token. For me it was already installed. We can just import tick token, and then we set this encoding. So we can refer to this table here to set the encoding, like which encoder we want to actually get the tokens. So for 4.0 and 4.0 mini we use this particular encoder, and for all these models we use this one, and so on. So so we can mention here whichever encoder we want. That is done using get encoding function. Tick token dot get encoding. We'll get an encoding object. If you don't know which encoding model there is, like if you don't have access to this table, let's say for some reason, you can directly initialize the encoding object using encoding from model as well. So you can directly provide model name rather than which encoder you want. So you don't really need this line. You can directly use this one. Since we are using 4.0 mini in our tutorial series, let's just initialize encoding using this rather than this model. Anyways, for 4.0 we are using this one and not this encoding. So this will initialize this encoding model. We are not running this line now. This is just for reference if you want. Like you can also set your encoding using this, the actual encoding name. And yeah, that's it. Like you can then use this encoding object to encode any string or any prompt that you have. You can ideally send any prompt that you want to actually look at the tokens. So this gives like IDs. So remember, like to LLM we always pass in the word IDs. I'm not sure like if they're internally OpenAI also exactly uses this exact IDs or not. Maybe they've mentioned somewhere and they actually use the exact IDs, but yeah, like anyways we can't do much even if we know the IDs. So so these are the IDs of for this string, how it's tokenized. So it has like six tokens, you can see. for these roughly three words. And if we want, we can get length of tokens as well. I mean, now this is manually countable, but if you have a large prompt, you can get the tokens using encoding and print the length of tokens to get the actual input prompt tokens. And one more thing to remember is when our LLM generates on the generation side, it generates token by token. So this encoding is a lossless encoding. They have mentioned somewhere here on the page as well. So they have explained like what is byte pair encoding and all. And these are the four major points that they have mentioned about this tokenizer, this byte pair encoding tokenizer. So one important, very major point here is like, so what it does is like at a very high level. Let's say in English, you have this like ing, like a common subword. So encoding is there, and you know like words like writing, reading, swimming. All these words had ing in it. So it's a very common occurring English subword, right? So what we can do is we can create a token for it because it's used at so many places. So it will be beneficial for us to like break it down into subword like this, kind of based on frequency to some extent. Like if it's more frequent, then break it, it will be more useful. So that sort of thing. Yeah, they have explained like encoding is broken into tokens like encode and ing instead of enc and oding, because oding might not be very common, enc won't be any common, but ing is very common. I don't know about encode, but yeah, ing is very common, so that explains. So this is one of the major 4 points. First point, they are saying like it's lossless. So for instance, now that we have gotten the tokens, we can also go back to the string from any tokens that are there. We can use the same encoding object that we initialized, and we use the decode method here, and we pass in the tokens that we have. So these are the token IDs basically that we have, and when we pass this, we get our string back. So you can use the decode method to get the string back in a lossless way. That's what this point means, like reversible and lossless. You can convert tokens back into original text. And then there are two other points like you can read and understand, but this fourth point is like the major one, I in my opinion. Yeah, you can also convert these IDs to actual like English readable text, so that you see like how exactly it's tokenized. So for that you use this decode single token by byte. So here you can see it's like T has been tokenized into one token, IKT. Here this has been broken down, and then token, and then space is, and then space great, yeah, and then exclamation mark. So this might not be very useful, like just to visually see how the tokens are looking, but generally we stop here getting the length of tokens just to see like how many tokens are there in any string. Yeah, that's it. Like that's literally the tokenizer. It's just a fun thing so that we know like how many tokens, like actually how the tokens are calculated for your string. This can be one useful thing. We might not need it anywhere. One thing, like one place where we might need it in projects is, what we do is generally we take the prompt, like depending on the use case, we try to see based on the length of tokens in our prompt whether to send it to a larger context model or a smaller context model. So for instance, if the length of token is already exceeding let's say 10k tokens, we'll send it to a bigger model compared to a smaller model. So that is one use case in our like while building projects. Tick token can still be very useful in that way. Just one more point about these tokenizers and tokens is, this token is kind of like a vocab for your LLM. This is what it can read, this is what it can write. That's it. That's nothing beyond these tokens. So that means like whatever tokens you have set during the training of the LLM, those are the only tokens it will be able to generate. and that's where you can sort of define what all languages your LLM can also generate. So these are all English tokens. These IDs we can see here, like these are all English alphabets. But you have like French or Hindi or Italian or whatever language tokens. Then and of course like you need a training data for that language. But having those tokens in the LLM's vocab is the first step, even before like you train any LLM with any data. You still need to have the tokens, those language tokens in the LLM's vocab. So yeah, OpenAI's vocab is very rich. It We have seen like it can generate like multiple languages, can understand, it can read different languages as well, and this tokens is the reason for that. Like there are like a lot of tokens from different languages as well present in the LLM's vocab, in OpenAI's LLM's vocab. Yeah, that's all for this video. In the next video, like we'll actually start building projects. So hope to see you in the next video soon. Bye.